my name is Sarah, and in this video we will be learning how to solve matrices with consistent independent solutions. So here's our system. Negative 3x plus 0y minus 4z equals negative 24, x minus y minus z equals 0, and 0x plus 2y plus z equals negative 6. So we're going to assign each of these equations a row, and I decided to put this one as row 3 because the first step we will be doing is solving for a 0 in the bottom left hand corner. So that's why if that's already there, then that would be very convenient for us. Okay, now we'll write our numbers into the matrix, as you can see. And okay, like I said before, the first step is to solve for a 0 in this corner, and since we've already got it, we're all good. Okay, our next step is to solve for a 0 in this place. So to do this, we have to use row 1, because if we use row 3, then that will cancel out the 0 that we already have there. So we use the equation 3r1 plus r2. And as you can see here, I've already done the work on this side. So now that we have a 0 in this side, our next step is to find a 0 right here where the 2 is. And using this, to do this we have to use row 2 because for the same reasons as we had to use row 1 in the other problem. And our equation would be 2r2 plus 3r3. And here's work on this side. As you see, negative 6 and 6 cancel each other out, so they become a 0. And our new equation would be our new row would be 0, 0, negative 11, and negative 66. Now our last step is to find stair-step ones, which means we have to find a 1 here, a 1 here, and a 1 here. And to do this, we multiply each row by a coefficient. So the first row, we don't have to do anything to it because there's already 1. But for the second row, we multiply it by negative 1/3 r2. And for the last row, we multiply it by negative 1 over 11 r3. And now we've simplified some of these equations by multiplying them. And our next step now is just to use back substitution to find the solutions to the variables. Okay, and as you can see, I've used x minus y minus z equals 0, y plus 7/3 z equals 8, and z equals 6. So we want to plug z equals 6 back into this equation. So it would be y plus 7/3 times 6 equals 8, and y plus 14 equals 8, and y equals negative 6. Now we know that y equals negative 6, and we can plug that into this equation along with z. So x plus 6 minus 6 equals 0. These 6's cancel out, and we get x equals 0. And our solution to the problem would be 0, negative 6, and 6. Now, if you wanted to check that on your calculator, you would go to second matrix, go to edit, enter, and now we just want to plug in our former matrix into here. So 1, negative 1, negative 1, 0, negative 3, 0, negative 4, negative 24, and 0, 2, 1, negative 6. Make sure to check that that you plugged everything in correctly. And after you've done this, go to second quit, back to second matrix, and then go to math and go down to letter B, which is reduce row echelon form. Press enter, and then you go back to second matrix, and then put in A, close the parentheses, and then press enter. And here you'll have your reduced row echelon form. So as you can see that x equals 0, y equals negative 6, and z equals 6, just like we had here in our solution. Okay, that's my video on solving matrices. Thanks for watching and have a nice day.